And good morning, everybody. Welcome to this session, which will be Civil 3D Survey Basics. I'm going to be your host. I'm Mark Shinesk with Seiler Design Solutions. And in this video, we're going to be discussing the Civil 3D Survey Database and how to set it up, both for regular survey database projects and also using the WisDot style format. A little bit about us here. Seiler Design Solutions provides informative, unbiased solutions to clients for using Autodesk software, geoslam scanners, point cab software, and drone solutions. We are a business that's incredibly talented individuals are empowered to do whatever it takes to provide you with the best, most affordable software solutions to fit your needs. Our clients trust us because we consistently provide them with reliable insights from experienced trainers, all backed by the best user support in the industry. Seiler Design Solutions is part of 5 distinct divisions owned and operated by Seiler Instrument and Manufacturing Company, Incorporated. Our industry specialists and application engineers are dedicated to understand your firm's workflows and are experienced in integrated services without sacrificing your productivity. A little bit about me. I'm an application engineer with Seiler Design Solutions. I'm a graduate of Michigan Technological University with an associate's in civil engineering technology. I have 30 years of experience in survey drafting, land development design, transportation site, and utility design. I am also an Autodesk certified instructor. I was also a MicroStation user for several years on that end of it as well. So I have a little understanding of what goes into making that transition, moving towards Autodesk products from other software. Today's session's learning objectives, we're going to understand the role of the survey database with Civil 3D, both internally and within the WisDot standards and practices environment. We're going to automate the representation of existing conditions, leverage the survey queries within the survey database to convey key site condition information, and be able to produce better deliverables to meet project requirements. Okay, so now we're going to talk a little bit about the background. Some of the things that we need to talk about when we're talking the Civil 3D Survey Database. We want to make sure that we're all on the same page. We're going to go over a little bit of basics here, okay? Throughout this session, we'll be showing some of these slides now, and I'll follow that up with a demonstration as we go along. So the first thing we need to understand are COGO points and survey points. You know, what are the differences, what they are. COGO stands for coordinate geometry. They're the basic building block and represent surveyed point objects or calculated positions. These would be positions that are collected with the data collector, GNSS, even mapping data type of collectors, or a COGO point can be a calculated point. I can come in and I have several different tools within Civil 3D to place points using standard COGO, intersect, distance, bearing, intersect, distance, along lines, dividing objects, use it for creating stakeout points, etc. Okay, you can place it in a drawing file via standard placement or calculation routines, or I can also just dump. I can import a batch file or a CSV file full of points too, and just do a point dump. Survey points are similar to COGO points. They are actually COGO points, but they're tied to the external survey database and always represent field collected data. Okay. The next thing we're going to talk about is survey figures. Survey figures are similar to feature lines. If you're familiar with the Civil 3D feature line, they represent 3D line work tied to survey points created via the survey database. A feature line is a smart 3D polyline that has both stationing and elevation PI points, PBI points. Well, a survey figure is the same thing, except they're tied to the survey database and they're influenced by the points that are placed. They're used to represent both linear features collected in the field, both topo and feature objects. Chain-based figures are edited via a point table, as you can see by the illustration here, or there are vector-based figures, and they can be manipulated similar to feature lines using the horizontal geometry edit tools and the vertical edit tools. The survey database itself, now, those are the objects that are created and held within the survey database. The database is a separate file from your DWG file. Civil 3D, all the objects like alignments and profiles, etc., are held within the drawing. Well, the survey database is an external file away from the drawing. It is a file and folder grouping to store survey point data and also survey figure data to use in multiple drawings. It's used to generate the survey figures, the coded line work, based upon your field codes, and it's independent of the drawing, can be used to import data over and over and over again with consistent results. Now let's take a second here in our Civil 3D drawing to explore some of these concepts. Here I have a drawing that shows some survey points and survey figures. Now the actual data that came into this drawing came from an external file, and that's the survey database. Now within Civil 3D, the survey database is located under your tool space under the tab called Survey. If your Survey tab does not show up, be sure to turn on that particular tab using the icon under the palettes in the Home tab here. Okay. Once we go to our Survey tab, you can see that I'm currently in a live survey database, the Franklin Seiler office, and it contains survey points and the figures that have been added to my drawing. So if I select the point here, you can see the point is a COGO point. However, if I come here to my prospector and I edit and list my points, you notice that my points are they're grayed out. I cannot edit any of them, and I have a new symbol on the side for what I'm used to seeing. This means these are survey points. I cannot edit these points within the drawing directly. I have to come back to the survey database and edit them if I need to. Okay, so that's a little concept. Again, these are survey figures then. The survey figures are the line work that gets created from the points using the line codes, then things we're going to discuss here in a second. Okay, moving back to the presentation. Before we begin using the survey database correctly and properly, there are several requirements that have to be taken into consideration. The drawing template must be complete with all required point styles, point label styles, and survey feature styles. The descriptor key set within the template maps the feature codes to point styles and point label styles, while the figure prefix database and line code library are independent external files that work in tandem with the drawing template to complete line work within the survey database. Now, the descriptor key set is part of the drawing template, complete with all required point styles, point label styles, and survey feature styles. Okay, but basically it takes the whatever feature code is given in the data file that's imported and says, okay, if I see this particular code, POLE, I'm going to bring in the existing pole symbol and also assign a point label style, in this case, as you see in the image here, default. Okay, that handles automatically. So that has to all be set up for each and every single one of your feature codes. Okay, you can also have multiple key sets can exist in your template. So let's say your company has two sets of survey figure keys. Maybe they do some of it alphanumeric, maybe some totally numeric. You can have both of those descriptor keys live within one single template. If it looks in the first one at the top of the list, if it can't find the code in the first one, it jumps to the second one and uses it when it finds it there. Okay, uses it in the preferred order. It can include special parameter codes like scale and rotate. So we could take like the second digit the second sentence or word in a description that could be a number and say, okay, we're going to take that number and we're going to apply a scale factor using whatever that number is. So maybe you have a tree code, say tree 4, then it's going to look at the tree code, put a tree symbol in the drawing, take that number 4, and if it's set up in the descriptor key, scale that tree maybe up 4 times to represent different tree sizes based upon the inputted data. The figure prefix database is created as an independent file, but it's tied to the template when created. Okay, it's an independent file, but you have to have your template file open when you create this because your survey figure styles are in the drawing, and when you create this feature code library, it's going to read into the drawing to pull those styles in. So it's kind of a weird situation, but that's the way it works. So it's an independent file, but it's tied to the template. The custom file type is typically located in the directory shown here under your program data Autodesk C3D, whatever year, and then ENU survey. It's a collection of feature codes associated with the linear features. And finally, the line code set controls how the lines are established, whether they're, the begin code, the continue code, the end, the begin curve, the recall. They're created also as an independent file, typically located in that same folder, collection of special line control codes. These are reserved words. You cannot use these as part of your description without Civil 3D interpreting them as a line code. It's going to skip it, eliminate it from the description, and use it as a line code. Okay, back in Civil 3D, let's discuss some of these concepts here. I'm using the Wisconsin DOT Survey Start template, and I want to show you the things that need to be set up for Survey Database. So in my Settings tab here, under Point, if I expand on that and go to Point Styles, you can see there are numerous point styles already set up in this template. These are all the different point styles that Wisconsin DOT uses. If you have your own company standards and own template, you would use your own based upon your own feature codes, your own symbology. All right. So each of these is a point style. So it has a typical of a block and a size and a color and a layer. Okay. We'd also have our label styles set up as well. The default being no display. Okay. And then we have what's called the description key set. So there's one in this particular template called Wiz.topography. If I right click and edit keys on that, you can see in the panorama we have your typical description key editor. On the left, we have the feature code. This is the first word of the description. So for point number northern easting elevation description, the very first word is the feature code. It can be numeric, it can be alpha, it depends on how you have it set up. You can see on these, there's an asterisk end of it. That means you can have numerous variations on a theme here. So for like post, I can have post 1, post 2, post 3, post 4. In the point styles, it really doesn't matter, but in the lines, I can run multiple lines at one time. So like peer is a line. So I can run peer 1, peer 2, peer 3. It would see peer asterisk, so it always use the peer symbol. Okay. Here it's going to tell you when it sees that first word, I could say peer space broken space old. It's going to look at peer and say, okay, if it sees that, it's going to use this style with this label style, put it on this layer, and continue on. And it does that for each and every field code that would be available in the survey. All right. And then down here at the bottom, we have survey in settings, figures and figure styles. These would be the survey figure styles. So we have survey figures loaded up in the template as well. Now we jump over here to the survey tab. Down here, below the survey. So our survey database is at the top. We talked about two other files, the figure prefix database and the line work code set. You'll also see equipment databases. We don't use those for CSV files. Those are only for raw data, and there's not going to be any raw data built into Civil 3D anymore. It's all CSV. So the figure prefix database, you can see Wiz.topography is highlighted. If I right click and manage, you can see these are the figures. So these are a subset of the descriptor key set, but only for those points that are used as part of a line. So if I come down there, if I sort by name, if I slide down here, let me come down here to the P's. I showed you that peer that was in the descriptor key. Here it is as a line code. So I can have a line of peer because it also appears in the figure prefix database. How does it know whether to use a line or not? That's down here under the line work code set. So finally, the line work code set determines, hey, if it sees a B, if I had my description peer 1, let's say, space B, space old, space, rotten, whatever, it says, oh, I'm going to begin a line of this Pier 1. And then the next shot down will be Pier 1 with no descriptor. It's going to connect the two together. And then the next line it finds a Pier 1, it's going to connect that. And the next time it finds a Pier 1, it's connect that. Until it finally reaches a Pier 1 space E, which is the end code, and then it ends that line. And then I can reuse Pier 1 to start with a new B if I wanted to. Or I could run Pier 1, 2, and 3 at the same time with no end codes, and it would just stop at the very last point that it got. Typically, I always put an end code. It lets you recycle those numbers again for the next day topo. The line work code set that WisDot uses is pretty much the standard default one that's used by, as far as Autodesk is concerned. So these are very common. I'll show you a quick, or include an image of the different functions that each of these special codes use. Okay, let's back to the presentation. Okay. Now we're actually going to get into starting a new survey database. There are two methods depending on if you are using a standalone company. If you're not doing WisDot style surveys, you can do it this way, where you just navigate to the survey database. You right-click on survey databases, choose New Local Survey Database, and create a database with your standard settings. The WisDot method is a little bit different because they have a lot of predetermined settings already done for you. All you got to do is copy that template to your working folder. Rename the folder to match the project name, and like the example I've given here. Right-click on it and choose Refresh, and it'll appear in your list of survey databases. Then you can then open for edit. Let's see how that looks. Okay, let's go through starting a survey database. I'm in my Civil 3D open, same drawing. I'm in my survey databases. One thing I did not mention is something called a working folder. So right here under survey databases, I would first need to right-click and set a working folder. And this is similar to data shortcuts. This is going to be either a common folder where you have multiple survey databases, or you have one working folder for each survey database. So here I have one common folder, my Civil 3D 2020 projects. I'm going to show you how to create one standalone. So with this working folder, the common one, let's say I'm going to make one for this class. I will say right-click, New Local Survey Database. I'll call this Wisconsin ACEC standalone. Okay, and then it creates that survey database and sets me up. And if I look back here under my working folder, there it just created that folder underneath there, and we're ready to go. Now the Wisconsin DOT one is a little bit different, and we're going to set up a standalone working folder. To close a survey database, you right-click on whatever's highlighted and say Close Survey Database. If I need to open it again, you just right-click and you say Open for Edit or Open for Read Only. So there is two different. If you're going to make new changes, you make sure you open for Edit. So to do the WisDot one here, we're going to go to a folder. So here I'm going to go to my C:WisDot under Standard. Now this is part of the state kit when you install it. You'll see SD 2020 template. I'm going to right-click and I'm going to copy this, all right? And then I'm going to browse to, back to my this PC. I'm going to my desktop. I have a project folder that I'm going to work on here under Design. This is a standard. Wisconsin DOT is my project number. Under Base Data, there's Survey. I'm going to paste it here under Base Data Survey. I'm going to right-click and say Paste. And then I'm going to rename it. For Wisconsin DOT, you typically rename it SD with the project number 1, 2, 3, 4, 5, 6, 7, 8. And then we're ready to go. You can see all the file. There's the SQLite file. There's my files are all in here. I'm ready to go. Back here in Civil 3D, now that I've done this, back in Civil 3D, I'm going to right-click. I got to set my working folder to that demo design C3D base data survey. Don't go one more deep. Leave that. That's my survey database. Say select folder, and there it appears, my survey database. So this is the way you do it for DOT. Then I can right-click on it, say open for edit, and I'm ready to go. Okay, back to the presentation. Okay. Once you import your data, before we process it and actually bring it into the database, we definitely have to make sure our database settings are set properly. When you right-click on the survey database name, choose Edit Survey Database Settings. We're going to make sure the distance is set properly to match our drawing. Our drawings are typically going to be in US foot. Our data is going to be in US foot. By default, Civil 3D comes loaded using international foot as its values, okay? So we're going to go into survey database settings for our particular survey database. We're always going to check and make sure our distance is US foot. If we don't do this, Civil 3D will think that our survey data is in international foot. If our drawing is set to be US survey foot, it will transform the points as it drops it in the drawing. So your coordinates are not going to match between the two. So this is very important. Now, you could set the coordinate zone here as well. It's not necessary unless you're doing a transformation between coordinate zones, like going from NAD 27 to 83 or something like that, or UTM or Latlon. You make sure you set your coordinate zone in the survey database, and you make sure you set it in the drawing, and then it will do a proper transformation of those points too. Okay. Once we're ready to import our data, it's typically going to be in two formats. It's either going to be in CSV, maybe .txt, maybe .xyz, but it's definitely going to just be a straight coordinate file, text file, usually the format of PNEZD, point, number, northing, easting, elevation, description. As far as your feature code goes, the first word of the description is your feature code. So you can have as many words as you want in your description, but Civil 3D looks at that first word and treats that as your feature code. So when you're coding these in the field, always make sure your first word is feature code. Next ones, you could be line code and so forth. I'll show you some examples on that as we get in. Or you can bring in an XML file. I know some data collectors, you need to transform from a certain format to XML, and you can read that XML file in. It'll also read that in the same fashion. Okay. You're going to right-click on the database name, import, and then import survey data, and then just follow the wizard along. And whether it's a text file or XML, it'll come in properly. Okay. Once we get those set, we're going to import our process our data. We have certain checks. We're going to process the line work as we go. And then once that's done, we can automatically import the figures and points into our drawing, or we can save that for later. So we can process it and say don't import, and then manually import in. There's two ways we're going to go about doing this. With Wisconsin DOT, they have certain things they want in certain drawings, okay? We have a utility drawing, a topo drawing, and a surface drawing. We're going to import those in different drawings, but we can also dump them all into a working drawing. That's typically what I do when I'm going to edit all my survey figures, because nothing's going to be perfect. Somebody's going to forget a line close. Somebody's going to forget a begin line, maybe missing a line. So we're going to go ahead and dump everything into one drawing. Then we're going to check and fix points and survey figures in this mass drawing. Points can be unlocked in the drawing to move, but if you move drawings in, the points are tied to the survey database. If you unlock them and move them in the drawing, they're kind of locked. All you're doing is modifying the drawing. If I was to re-import my points from the survey database, it'll fix those points and put it right back to where it was, okay? So we must be corrected in the database. Survey figures, on the other hand, can be edited in the drawing, and then if depending on if they're vector or coded ones, it'll automatically update the survey database, or you write them back to the survey database. You can also create survey figures brand new from the drawing and write those to the survey database as well. Okay, let's put it into practice here. We have our survey database open. We're ready to import our data. I am using the correct template that has the point codes, the descriptor key set, and the figure prefix database, the survey figures. So let's go ahead and import some data. I'm going to right-click on the name. First thing I'm going to do is edit my survey database settings and make sure. Now, the DOT template method This is set to US foot by itself. Typically, the default template, if you're not using that, will be international feet, so you need to make sure you set this to US foot. If you do not, and your drawing settings are set to US foot, you're going to transform the points. Your coordinates in survey database will not match the drawing, so make sure that's done, please. Okay, so then we're going to right click and we're going to go ahead import and import survey data. Now, if you want to import a survey point file directly, you can go here or land XML here. I like to follow the wizard just for this demonstration. You can experiment with the rest of these as you see fit. But we'll say import survey data. Okay, this is our database, a specified database. Go ahead and hit next. We are going to bring in a land XML file, so I'm going to switch this from point file to land XML, and I'm going to browse for that. And I'm going to bring in, there's the first one. I'm already keyed right into it. And I'm going to select it and hit open. Hit next. Now on this page right here, I can expand this out. We remember, we got to use the right survey figure prefix database. So equipment, we don't have to worry about it. The equipment, remember, there's no equipment, so you can leave these as sample. We got to make sure we're using the wiz.topography, which we are. Process line work during import, yes. Current line work code set is wiz dot. Here's the event name. I can determine whether this first time around, maybe I won't insert them. I'm going to say no to insert them and just let it go. Go ahead and hit finish, and it has brought that data in and calculated out. Now I said do not import into my drawing. Well, now you notice I have a little black dot next here to figures and next to survey points. I can now right click next to figures and say insert into drawing. And there's my line work, survey points, right click, points, insert into drawing, and it inserts all my points. Okay. And it's using the right feature code based upon the point code. If I look at COGO point here, it's a survey point, raw description TPOL. The descriptor key set says use EU till telephone pole, put it on EU till telephone pole layer. So that's all taken care of. And because I look at the first line here, if I come up the line, nope, not that one, maybe the other one. No, that one doesn't have the begin. I'm not sure where my begin code is. It's probably this one right here. So one of these has a begin code on it that would begin the line. Let's do the other file too and bring it in. So let's say that's day 1 event. If I have multiple days of events, I just go ahead and keep bringing them into the same database and keep adding to the file set. So again, I'll right click here. I'll say import. I'm just going to go directly to import land XML. It just skips a bot and says, okay, choose your next file. There's my next file. I'll hit open. And then it just jumps me directly to this next same one. This time I'm going to choose to import them directly. So now after it processes this, it's just going to dump them in the drawing in one shot. Boom. So that was some bridge work and some points. All right, and sometimes it zooms you way out. If it does, don't worry, just zoom extents again. Now you can see I have all my points in there, point styles, point lines, etc., based upon my drawing. So this is a default survey database. Now I can go ahead here and edit those points and files here. One thing I am going to do is change my point group. I'm going to update those. There we go. And then it has all my lines on here. Typically, when I'm working with a survey file, I usually turn my scale down to like 1 to 10 so I can see what's going on here without getting lost with all the point dump information. But you can see there's the point number, the elevation, and the line work. So I got a little bit of line work editing to do. I also have some lines that weren't coded right. So to show you the difference between editing survey figures. Now, if I wanted to move a point here, like this guy pole, I can't just move it, it's locked. So I actually have to find this point, 4241, here in the survey database, under survey points, I have to right click. I could find point 4241. So I got to come down here. 4240. Oops, there it goes. I passed it. I'm too fast for my own good here. 4241. And I'd have to manually change the northing and easting here. Let's say if I wanted to bump it like 3 feet east, I could type 44 and hit enter, and then I would have to save it. And then once I do it, then I'd have to right click and say points update or points insert in the drawing, and then it would show that bump over. So editing points is a little more difficult. It might be easier to go back to the original data file and edit your northings and eastings there, and then write them back here a second time. If I re-import any of these events, it'll delete and overwrite the points that are in the drawing and in the database. Now, survey figures, on the other hand, here I got a survey figure that's a P-pole. Well, that's not really a line code anymore. I need a different line code, like maybe overhead. So I'm going to edit this. Now, survey figures here, when I highlight it, you can see I get survey figure properties. Right now, it's showing me each of the 4 points that it's running through, and it's given it a name and a style. So it doesn't know what style it is. So I'm going to rename it from P-pole 41 to overhead 41. And then I'm going to change the style here from standard to, I think I have an E-util, overhead utility. Overhead utility. Okay. And then I'm going to hit OK. And that will update that point. And not only does it update it here, but it updates it back in my survey database. So then I can go through, let's say if I wanted to split the line or move a line, I can use this. Oops, I can only choose one at a time. I can do the same thing with this one here, survey figure properties. I don't have to change the name of it. I can tell it, say, hey, just use E-util overhead. And it will do that, or E-electric manhole or electric vault, overhead utility. Okay, and say that back. You could use other tools in this set here as well, in the survey figure properties to add a point or delete a point. If I wanted to split this, let's say there's a break between these 2 points, I can come here and I can say, hey, let's add a break and break this into 2, and that's going to ask me to name, I'll call this overhead 42. Okay, and now it's broken this into 2 separate survey figures, and then maybe I can delete that point from the survey figure, and that will let me break that survey figure. Again, these are permanent changes that are being written back to the survey database. If I wanted to, let's say, add these together, I can simply maybe draw a line between this COGO point and this COGO point here. And then under figures here, I can right click and I can say, create figure from object. And I'm going to call this name. I'll call this overhead 99. An additional way you can edit survey figures as well is using the same tools that you use for a feature line. Where if I selected the survey figure, I can expand on my edit geometry or my edit elevations tab. Do something simple as select an object to break. Start with my first point at this end, my last point at this end here, and then it would break that. Once I've done that, then I have to come here, select my survey figures again, and say update survey data from drawing, and that would write this survey data back to the survey database, and that would make that a permanent change. And then we're going to talk about survey queries. Once we get our database all set up and cleaned up, then we're going to write our files down. Survey queries are really important to use for WisDOT. It's the WisDOT preferred method of bringing in your data. So I'm going to set up my 3 drawings. I'm going to set up my topo drawing. I'm going to set up my my utility drawing, and I'm going to set up my my surface feature drawing, and I'm going to use the survey queries to bring those in. Now, survey queries, it's just a way to filter points. So I could set up a survey query, give it a name, and use a lot of logical operators to filter out my points. Okay, the WisDOT template, when you copied that template over, it had them all in there. So we have one for center lines, control points, surface figures, 3 surface points, topo figures, 2 topo points, and 2 utility points. Why do we have so many duplicates? Because there's a limit of 25 definitions per query. So we have to use multiple queries to make sure that we can cover all the points that we need. Points or figures are read directly into the survey surface definition as well via query. So as we go into surface, when we finally make our Civil 3D surface, when you go into your definitions, you'll notice there's 2 places at the bottom for survey point query and survey figure query. So queries can also be used to directly plug points and survey figures directly into a surface without having to load them via point group or by selecting them in the drawing. All right, back into our Civil 3D drawing set again. Actually, I have blank drawings. I have 3 blank drawings that have been created. Because this is the WisDOT style, I'm using the Wisconsin DOT template, the Survey Start DWT. What I'm going to do is I'm going to break my survey database out into 3 separate drawings. So opening for edit, we're going to talk about the survey queries again. So now I can bring in data from the survey queries. Let's say I had a center line, control, and alignment. I could bring those into a drawing. Basically, I'm going to bring into 3 different drawings. I'll have my surface drawing, my topo drawing, and my utility drawing. My surface drawing will be for building my tin, topo for my existing ground features, and the utility for the utilities. So this first drawing here, let's start with the surface data. So I have all these survey queries. If you look at them, the figures are easy. If it is a break line. So back here, one thing I failed to mention, down here in the figure prefix database definition, for each one of these figure prefixes, we can say whether yes or no, it's a break line. It's just a switch. Yes, it is. It doesn't. I can make all of these into a break line to a survey surface if I wanted to. But if I automatically have them checked, then it becomes a logical thing that I can filter out, okay? So back here, I can say surface figures. If I edit that query, it's going to say, hey, is a break line equal to true? That's it. And if it's equal to true, then execute that as part of the query. So for this query, I can right-click, and I can say insert into drawing. Now, these are all true. These are all survey figures that are true for a surface. Surface points 1, insert into a drawing. Surface points 2, insert into a drawing. Surface points 3, insert into a drawing. So not only do I have surface points and surface figures, these are XYZ, these are ground points. These can all be part of a surface. So I can make a surface here, a surface here. These are additional surface points to something that's already been, so I can add these into another surface if I want to. We're going to go ahead and make a surface out of these. Next drawing would be my topo drawing. So it's blank. Topo figures, insert in a drawing. Notice we have overlap. These are the surface figures, but I can also use them as my existing topo background. Topo points, insert into drawing. Topo points 2, insert in a drawing. Okay, this just tells me there's nothing that satisfies that. So I had a couple guy poles in here and a benchmark that satisfied only points for my topo. So this becomes my topo drawing. And the last drawing is going to be my utility drawing. And here I can bring my utility points or lines in, and utility points, and more utility points. There we go. So here's some power poles and some overhead lines. So these are all things that become utility points, utility figures. And now the query is not 100%. Notice I'm missing some overhead. I guess I have to go back through and see why these didn't come in as part of my query. Maybe go back through and check my database, make sure those lines are the right code so that the query can. It's a good thing, that's why we go through and check these things. But there you see my 3 basic drawings set to go. And then I save these with the correct file name in this correct folder structure, and then we're ready to go. So what about my surface? So going back here to my drawing, let's go ahead and build a surface. So here in my prospector, go to my home tab. I'll go ahead and I'll make a new surface. We'll call this surface EG by query. Why not? Style, we'll use existing contours 1 and 5. Perfect. All right. So now instead of definition, normally my definition, if I was used to doing this, I might come down here and add my points. I have these as a point group, and then import my point groups, and then my break lines, for my break line points. But now down here at the bottom, I have my point survey queries and figure survey queries. So I can right click here and say add, and add that surface points 1. Boom. And then right click and say add, and add surface points 2. Once 1 is gone, boom. And right click and add surface points 3. Now I got some disparate, just separate, results here because, I'm really concentrating the bridge, and I'll add a boundary in here to fix it up. But same thing with queries of figures. I can say add and make sure it's adding surface figures, and those are in there now. So that was my quick way. Now maybe I'll just quickly draw a polyline around what I want to keep. I don't care about that stuff on the outside for this particular model. There we go. And then boundary, add. Oops. Is that closed? Closed. Yes. There we go. Boundaries, add outer boundary. There we go. Anyway, and then I can modify this as I need to trim off, extra lines or whatnot. So there we go. I could have done this as what's the boundary I'm looking for here? A data clip instead, and then I wouldn't have seen any of this other stuff. So I can make, anyways, that would brought in my survey figures, my survey lines by query instead of. And then the nice thing about the queries now is this is a live thing to the survey database. So if I make changes or addition to my survey database, let's say I do add the remaining line points out here and I want to include all that, those can reflect back in through these queries. I can rerun the queries on the surface, and it'll read them right from the survey database. I didn't need any of this stuff in here. I could have started with a totally blank drawing and done it that way. So that's how survey queries work. Finally, the last thing I want to talk about is databases. So once you get all your data running, realize that pre-Civil 3D 2020 databases, if you want to continue using databases from older projects, they're in SQL CE format. You must use a tool called the Survey Database Migration Utility to bring those up to 2020. Okay, 2020 databases are in SQLite, and they are not backwards compatible to previous versions. So you go ahead and you download this tool from your Autodesk account. You run it and you browse to the folder where your survey database lives. You give it a new output. It cannot be the same folder. This tool guarantees that you won't lose your original data because it's going to force you to use a new directory, and it will convert your survey database over to the SQLite format so it could be used in 2020 and 2021. Okay? Well, thank you very much, and that covers everything. I'd like to invite you to come join us at our blog. I'll have a copy of this video up. I'm sure the fine folks at the ACEC is going to have these all available for viewing as well. But we'll copy this also to our blog after the presentations are all done. You can subscribe to our blog at http://seiler-ds.com/blog. And we have tips and tricks for Autodesk products, GeoSLAM products, drone, Pix4D, Autodesk news, all sorts of good tools, tips, and tricks. You can also contact us directly at cadtechnical@seilerinst.com if you have any questions or if you need any kind of support. And I thank you very much for attending this session. If you have any questions, feel free to email us, and have a great day. Enjoy the rest of the videos. Thank you. Bye-bye.